All right, tonight's lesson is all about the synthetics. Synthetic substitution and then going into synthetic division. It's the same process, but we draw a few different conclusions. First of all, synthetic substitution is just a shorter way of doing plug and chug, especially if you have a big polynomial like this one. So look, I've got this big polynomial equation, 3x to the fourth plus blah, 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 and I want to evaluate for x is -2. Well, if I do it the old school way, then that means I'm just going to substitute in -2 for all my x's, and if the numbers aren't too big, then I don't need a calculator. But now we're going to do it the synthetic way, which means this number right here is going to go in my little corner box, and then I'm going to take all of my coefficients for every single term, and I have to make sure I have all of my degrees accounted for. So notice I go from a 4, a 3, a 2 to an x to the 0 power, which is what a constant is. So that means I have to account for my missing x to the first power in between. So all my coefficients are 3, 2, -1, 0, and 5. I draw my line, and now let's do our synthetic substitution. The first number comes straight down. I multiply diagonally, and I put the number here. And then I add straight up and down. And then we just repeat the process until we've filled up all the lines. I multiply diagonally, put the number here, +8 because I have two negatives. I add straight up and down. Let's do it again. Multiply diagonally, put the number here, add straight up and down, and then I have to do it one more time. Multiply diagonally, put the number here, and add straight up and down. This last number is my answer. So this means f of -2 is 33. I would have gotten the same answer if I plugged in -2 for all of my x's. But to me, this sure works out a lot faster, and I think there's less room for error. Okay, so when you're evaluating, the last number is the answer. Let's see what happens when we're doing synthetic division. So in synthetic division, if our last number is a 0, then that means it divides evenly. If it divides evenly, then it's a factor. So let's look at this example. The divisor is what I'm dividing by, which is x minus 2. Now remember, if x minus 2 is a factor, then that means x equals 2, that means x equals 2 is my solution, is an x-intercept or a root. So that's the number that's going to go in my corner. So now I got to list all my coefficients. So notice I jump from a 4 to a 2, which means I have to account for a third power right there. So my coefficients are 1, 0, -3, 2, and -1. Now I do the exact same process I did before. 1 comes down. 2 times 1 is 2. Add straight up and down. 2 times 2 is 4. Add straight up and down. 2 times 1 is 2. Add straight up and down. 2 times 4 is 8. Add straight up and down. So this last number is my remainder. And these front numbers are now the coefficients of my quotient. Okay, so that's just, a quotient is just the answer when you divide something. So now, to figure out what degree it is, I look at my starting degree. So since this is a degree 4 equation, this is going to be a degree 3 polynomial, which means this is degree 2 right here. That's x to the first power, and that's my constant. These are all positives, so I just put pluses in between. So my polynomial, that's my answer, is x cubed plus 2x squared plus x plus 4, and then I have a remainder of 7. Hopefully that made sense. If I have a remainder of 0, then it's just the polynomial, obviously without the remainder. Okay, so this is obviously not a factor. X minus 2 is not a factor. I think that's it. Hopefully that'll take you through the worksheet. So hopefully that helped you, Brad. See you tomorrow.